All right, good. This is a review for Unit 4 test. First 4 questions are graph questions, so we're going to start with number 1. Y equals 2 to the x, so that's our exponential function. I graphed it right here for you. All right, so we're going to do domain, range, asymptote, increase, decrease, positive, negative, and end behavior. So for exponential function, we always have an asymptote. This asymptote is going to be horizontal, and it's going along these lines right here, and it's crossing 0 at y-axis. Okay, so our asymptote says y equals 0. Now, we are asked what is a domain and what is range. Okay, domain is going to be freely going left to right because we do not have anything stopping it, so there's no asymptote. So we can go from left to right, from negative infinity to positive infinity. So we can say that our domain is negative infinity to positive infinity, or you can say that this is all real numbers. Now, regarding a range, we're going up and down. Unfortunately, because we have an asymptote right here, our function cannot pass 0. So that means that our range means our y-axis is going to go from that 0 up. This is where our function is. So that means it's all of the values of y that are more than 0. Okay? So all the positive values that are greater than 0. Okay? Now, the second question is asking us for asymptote on the list. Okay, so that's going to be at y equals 0. Now the next one is increase or decrease. All right, this function is going to have either or. We always looking through left to right when we talking about increase and decrease. So looking from left to right, our function is increasing. Okay, so we do not have a decreasing function right here. So you can put NA on the decrease. Now it is increasing, again, freely from left to the right, okay? So it's coming from negative infinity to positive infinity, okay? So negative infinity to positive infinity, because it's coming from here, and it's going to continue to grow toward the right, okay? Toward positive infinity. All right, now positive and negative numbers. Now, remember, positive numbers and negative numbers are identified by looking at a function. So whatever the part of the function is above x-axis will be positive numbers. Whatever part of the function is below x-axis will be negative numbers. So looking at my function is approaching my asymptote at 0 and does not cross 0, which means it's not crossing x-axis. So I can say that all of my values are going to be positive, okay? I will have no negative values. Now, what's the range of the positive values? Well, again, because I don't have anything stopping, my positive values are going to continue to grow from left to the right, okay? So I can say that I'm coming from negative infinity again to positive infinity with the open bracket. All right. Now, end behavior. End behavior is represented by, as x approaches something, let me write it down here. As x approaches one side, something happens to the function. And then again, as x approaches another side, something happens to the function. Okay? So now because we have an asymptote, one of the sides is going to approach that asymptote. So if I'm looking on the positive side, as I am going toward my positive numbers, so as my x's are approaching my positive numbers, my function is traveling up. So as I'm approaching my positive numbers, my function is going to be going up. Now on the other side, if I'm going to keep going this way, and as I am approaching my negative numbers on the x, my x's are approaching negative numbers, my function is going to be approaching that asymptote. Okay? So as I am going toward the left, toward the negative side of the x's, my function is approaching the asymptote, which is at 0, and it's going to continue to get closer and closer to 0, but it will never reach it. Okay? So again, right here, okay, as I am going to the left, toward my negative x's, okay, my function is going to keep approaching that asymptote. Okay? So again, we can just rewrite it here. This is all real numbers. Y is greater than 0. Asymptote is at 0. My increase is negative infinity to positive infinity. There's no decrease. Okay, positive numbers, NA for negative, and end behavior as x approaches positive infinity, my function was going up, and as x approached negative infinity, my function, because it's an exponential, will travel toward the asymptote, okay? All right, number 2, it's a log function. So again, a log function right here. All right, log function right here. Again, for the log function, my asymptote is vertical, and this is a standard log function. So again, my asymptote is going to be at x equals 0. Okay, so my asymptote is x equals 0, my domain and my range. So this is the opposite, right? Because they're inverses of each other. So now domain, it's going to have some kind of value, and then the range is going to be all real numbers. Why? Because I don't have anything stopping me going up and down. Okay, this function has no asymptote, it has no end, it continues to grow up and it continues to travel down. So my range will be all real numbers, or negative infinity to positive infinity. Now, regarding my domain, I have this asymptote, which means I can go to the right, but I cannot go past that asymptote. So I can say that my function is on the right of that wall, so on the right of that asymptote. So that means I have to have all the x's that are greater than this 0. So whatever that asymptote is, it's going to be all the x's that are greater than 0. It is not greater or equal to. Why? Because that function will never reach that asymptote. That function will get as close as possible, it will never get there, okay? All right, now we have interval of increase and decrease. So again, erase that. This function, reading it left to right, it is increasing. So for decrease, I will have NA, doesn't exist. But the increase, okay, again, we're reading it off x-axis, so it's increasing, starting at 0, because that's where my asymptote is, and it is traveling to the right toward positive infinity, okay? So again, it starts at 0, and it is traveling toward the right. So if I'm talking about increasing, my function is increasing in this range right here. It's traveling from the asymptote 0 to positive infinity, okay? All right, now positive and negative numbers. Again, it's the numbers, positive numbers are going to be the numbers that are above the 0, and negative numbers are going to be the ones below the 0. So positive number is going to be all of these, okay? And negative numbers are going to be all of these, okay? Right here. Okay, so again, you're reading positive and negative numbers, okay, on the x-axis. So I can say that my positive numbers, okay, start at 1, okay, and then they continue toward positive infinity, okay? So 1 toward positive infinity. Now my negative numbers, okay, they start at, all right, and the negative numbers are going to go from your asymptote, which is at 0 to 1. So this piece right here, this is where your negative numbers are. So from 0 to 1, okay? Now, you can also put it on the number line if you prefer, okay? And you're going to mark the point at 1 right here, okay? Okay, this is where they change, all right? Now, you have infinity, and you have negative infinity, and then you have your asymptote at 0, okay? Now, if you're looking at the number line, your positive numbers, okay, are in this range from 1 to infinity. They're right here. Your negative numbers are from between the asymptote and 1. So this is your negative, okay, and this is your positive. Okay, so I can write now negative numbers again from 0 to 1, and I can write that from 1 to infinity are my positive numbers. So then again, you can use a number line to be able to do it. All right? Okay, if you need to write it down, pause it, I'm going to erase that. All right, now we're going to do end behavior. So again, end behavior always works as x is approaching something, the function is going somewhere, okay? So I have first as x approaches positive infinity. So again, as x is approaching positive infinity, meaning as my x is approaching positive numbers here, they're growing and positive. My function is going up, okay? So as I'm going toward positive numbers, my function is traveling up. Now, on the other hand, if I'm going to go toward negative numbers, unfortunately, I'm not able to do that. I cannot reach negative side, okay? Why? Because I have an asymptote here. This asymptote stops me from being able to reach that negative side. So I can say that on the left side, okay, this is your left, this is your right. On the left side, I am traveling toward the asymptote. I'm not traveling toward negative numbers. I am traveling toward this asymptote right here, and this is where I'm going to stop, okay? When I reach that asymptote, which is 0, my function, I'm going to follow this function along that line right here, okay? My function then travels down, okay? I'm going to follow along that asymptote line so that my function is traveling toward negative infinity, okay? So again, on the left side for a log function, I cannot reach the negative side. I am reaching the asymptote, which is at 0, and then when I reach that wall, my function will travel down, all right? Okay, so here, we're just gonna rewrite that. X is greater than 0. Range was all real numbers. Asymptote was at 0. It went from 0 to infinity. There was no decreasing. Positive was from 1 to infinity, and negative was from 0 to 1. And the end behavior was when a function approached positive numbers, my function approached positive infinity. And then again, when a function was approaching 0, when x is approached 0, my function approached negative infinity, okay? All right, moving on to the next one. Next function right here. It is 2 raised to the x minus 3 plus 1. Again, so this function had a little bit of a transformation. So it went up 1 and 3 to the right. So it is viewed to you right here. Close that. All right. So again, this is an exponential function. So my asymptote is going to be right here. Okay. Right along this line, and it looks like it's going through y equals 1. Okay, so that's my asymptote. All right. Now again, we are asked for domain and range. So again, for exponential functions, domain will always be all real numbers. Range, on the other hand, cannot pass up and down through the asymptote. So range is in the place, it's going to be going 1, and our function is above that 1. So it's going to be all the values of y that are greater than 1. Okay? Now again, asymptote is at y equals 1. Now, you do have a transformations here. So like I said, we're going to look at the transformation right here. The function was y equals 2 to the x minus 3 plus 1. Okay, so this one says that it went up 1. This negative 3 is the opposite. It's going to say it went right 3. Okay, so these are your transformations. We move up 1 and 3 to the right. Okay. Now, increase, decrease. So this function reading left to right, again, it is increasing. So we will have no decrease. Okay, so decrease is going to be NA. Okay, now increase, on the other hand, it is increasing from negative infinity to positive infinity because, again, there is nothing stopping it. Okay. Now, positive numbers, again, positive numbers, negative numbers, this is your x-axis, whatever it's above or below, everything is above, so that means positive are going to be negative infinity to positive infinity, looking left to right, and there is no negatives. Okay, everything is above 0. Now, end behavior, again, we're looking to the left and right. This is your left, which is negative infinity. This is your right, which is positive infinity. And don't forget that your asymptote is right here. So that means if I am looking to the right and my function is traveling to the right, okay, toward my x's are growing toward positive numbers, I'm going to reach my function to go up. So as x is approaching positive side, the right side, okay, my function is traveling up. Now, if I am approaching the left side, means my negative, okay, so this is left, as x approaches negative infinity x's, my function is going to be traveling toward my asymptote, okay, which is at 1. My function will never reach that 1. It will just travel toward, okay? All right, so again, that's it for this one. So we can finish it up, all real numbers. Y is greater than 1, y equals 1, okay? Right 3, up 1. It is increasing from infinity to infinity. And A, positive are again, infinity to infinity, and A. And as x approaches positive infinity, my function is traveling up. But when x is going to the left toward negative infinity, my function is trying to approach the asymptote at 1. Okay? And then the last function again, some of the transformations right here, I can already tell you about looking. That 1, it's going to be a transformation to go down by 1. And then the 3 is going to be the opposite. Instead of the plus, we're going to say we're going to go left 3. Okay? So let me show you the graph for that. All right, the last graph right here. So again, this is a log function, which means my asymptote is going to be vertical. So it's going to be right here, whatever the flatter line is. Okay, whatever the flatter line is, it's always vertical. So that looks like my asymptote. Oopsie, sorry about that. It looks like my asymptote. Where did it go? Hold on. All right, sorry about that. So again, the asymptote right here. Let me move that graph down. It looks like it's going through negative 3. So that's going to be the flatter line. So again, my asymptote here is going through x equals negative 3. Domain and range. Again, range for the log function goes up and down fairly. There's nothing stopping it. So that's all real numbers or negative infinity to positive infinity. Okay. Now, on the other hand, for domain, it's always going to be the asymptote. So that means I'm going to look at this and say, okay, on which side of the wall or on which side of that asymptote is my function? It's on this side. Okay. So x has to be greater than this number, which is negative 3. Okay. Because I'm going from here this way. So that means domain is all the values of x that are greater than negative 3. Okay. All right. Next one is transformations, which we already did. Left 3, down 1. Now interval of increase and decrease. Again, let's see where this function changes and goes above 0. Okay, at 7 right here. So from here this way, it's positive numbers. Okay, now from here all the way down here, these are all below 0, all these numbers. Okay, these are negative. Okay, and that's at 7. All right, so I can say that from this number, negative 3 to 7, so going from my asymptote to 7, all the values are below 0. Okay, so my negative numbers are going to be from negative 3 to 7. Okay, now positive numbers are going to go, and I can again move that a little bit. It's going to change it. Positive numbers are going to be going from 7 toward positive infinity. Okay, because they will not have an ending. So from 7 to positive infinity. Okay, because again, if I erase that right here, I'll show you guys because I got to move the function a little bit. We can move the function this way. As you can see, from 7, which is here, all of these values are above 0. Okay, toward positive infinity. And then the other values. So again, from 7 to positive infinity are positive, negative 3 to 7 are negative. Okay? All right, let's move the function back up here. Okay? All right, now we can talk about Now we can talk about increase, decrease. Again, this function is increasing, going from left to right. Okay, so increase is going to be from your asymptote, which is -3, toward positive infinity. Okay, that's the range or section that is increasing. Okay, now it is not decreasing, so decreasing will be NA. And now end behavior. Again, one side is going to go free toward an infinity, another side is going to go toward an asymptote. So if I go to the right side toward positive infinity, okay, as I'm traveling here, my function is trying to travel up. Okay, so as you're looking right here, if I'm going, my function is trying to go up. Okay, so that means my function is traveling up. Now on the left side, my function cannot get to negative infinity. On the left side, my function is going toward -3. Okay, so if I go the other way around, I'm going this way, I'm going to reach -3, and that's where I'm going to stop. When I reach -3, whatever the flat line follows down or up, this is where my function is going. Okay, so my function in this case is going down, going toward negative numbers. Okay, all right, let's fill that in right here very quick. So domain was all the x is greater than -3. Range was all real numbers. Asymptote was at x equals -3. Increase was from -3 to positive infinity. There was no decrease. Positive numbers were 7 to infinity, and negative numbers were -3 to 7. And then end behavior, on the right side, on the positive side, my function was traveling up. And on the negative side, I was traveling toward the asymptote. And when I hit the asymptote, my function traveled down. All right, moving on to the next one, number 5. So now we're going to find an inverse, okay? So remember, the first thing to find an inverse is going to be switching x and a y, okay? So I'm going to switch x and a y in this equation, all right? And now, because the log of base 6 of y is by itself, I don't got to do anything. So all I have to do is convert it into an exponential function. So again, 6 is my base. I'm going to raise it to what's on another side, and it will equal y. Okay? Now, y to a -1 represents an inverse. So anytime you guys have y to a -1 and then a function, that function is an inverse. The same thing if you have an f of x to a -1, that just means inverse function, okay? So that -1 does not mean anything other than a scientific notation. It does not do anything. You don't gotta flip it or anything like that. It just simply means an inverse, okay? All right, question 6. Again, this is an exponential function, so we got to find an inverse, which is going to be a log function. So again, I'm going to switch x and a y. So this is 5 to the y plus 7 plus 2. Now, I want 5 to the y plus 7 to be by itself before I can turn it into a log. So I'm going to move the 2 by subtracting it, which is the opposite of a plus, okay? Now, x minus 2 on one side and 5 to the y plus 7 stays, okay? Now, because of the exponent itself, it's by itself, I can turn it into a log. So, I know this is my base. Base is what holds the exponent, okay? So that means I can do a log base 5. Now, it's going to be x minus 2 here. Why? Because I cannot have, if I have 5 and y plus 7 on this side together, I cannot have a 5 and y plus 7 on this side. That's why I'm going to put the opposite on the log, okay? And then y plus 7 goes here. And now, of course, to finish this function, y got to be by itself, so I'm going to subtract the 7 from both sides. Now, the key is that this is going to be a log base 5 of x minus 2, and the 7 goes to the side of the y, okay? 7 does not belong. 7 does not belong to the 2 or the x. You do not combine it. You're not simplifying anything. You are simply rearranging their places, okay? So that's your inverse function. All right, number 7. This is ln, and remember that inverse function of ln is e. So again, we're going to turn it into an e, which is an exponential function. But first, we're going to make sure that ln, just like a log, will have to be by itself. So I'm going to move the 5. Now, I'm not going to subtract the 5. I'm going to divide by a 5. because there is a multiplication in between there. So that means to move it, I got to divide it. But before I do that, I got to switch x and a y. Because again, I am finding an inverse. Now I'm dividing this by 5, which means I got to divide the x by 5. Okay? Now I get x over 5 equals ln of y minus 3. Okay? Now ln is by itself. I'm ready to turn it into an e. Remember that there is an e there as a base. So this is going to be e as my base raised to, again, what's on another side, equals y minus 3. Because I already had y and minus 3 here next to each other, I cannot put them back together again. Okay, they got to be separated. Now, of course, the only last thing to do is add 3 and add 3. So your e raised to an x over 5 plus 3 on the side will equal your inverse. Okay, but again, you cannot add this 3 to the exponent. It goes to the side of it. Okay. All right.
I didn't get that. Could you?
All right, now solve for indicated variable. So what we're going to do here. All right, so here all we have to do is just rearrange it again and solve for a different variable, means different letter, okay? So I'm solving for t. T is right here. So I have an a equals PER times t. So this is just like what we just did with the exponential function. I need to get rid of the p to have an e by itself. So I'm going to get rid of the p by dividing it, okay? Now I get a over p on this side equals e to a rate times time. Now, I'm going to convert it into an ln, which is a natural log, to get rid of that e, okay? So ln over base e, because again, this is what holds the exponent, okay, of a over p, which is on another side, will now equal the exponent itself, okay? Now, to solve for t, all I have to do is get rid of the r, so that means I'm going to divide both sides by r. Okay, so d is going to cancel out. So at the end, you're going to get ln of base e. You don't have to write it base e. It's assumed of a over p divided by r equals t. So all I did was rearrange my letters. Okay, so I moved them, divided them, and subtracted and stuff like that. Okay. All right. Number 9 is the same thing. I'm solving for y, so I'm solving here. So again, I have an x times 5 to the y, t equals z. Okay. So first, to get the 5 to a y over t by itself, I'm going to divide both sides by x. Okay, I'm going to get rid of this x. And since there is a multiplication there, I'm going to divide by it. Okay, now I get 5 raised to a yt equals z over x. Now I can turn this into a log, because this is an exponential function, to get rid of that exponent, to bring that exponent down. So my base is 5. Okay, so 5 goes here. Now again, I cannot have 5 and y over t here together. I can't. So I'm going to put whatever is on the other side over z over x equals the exponent itself. Okay, now since you are solving for y, I'm going to take it and divide both sides by t and divide both sides by t. Okay, so your final answer is going to be log base 5 of z over x divided by t. And that's y equals. Okay, because we were solving for y. All right. All right. And now the last one, you are solving for a. So again, you're solving for a. So this already is set up to be ready. Oopsie, to be ready to turn it into an exponential function, because we don't have anything in the front of the log or added or subtracted from a log. So I know that not written, it's assumed to be a base 10. So I can take this base 10, raise it to a b, and that will equal a times c. Now, since I'm solving for a, I got to get rid of the c, so all I'm going to do is divide both sides by c. They're going to cancel, and your final answer is just simply going to be a equals 10 raised to the b over c. Okay? All right.